Hello guys, thanks for joining us today. Today we don't have a light talk, but instead of it we have a conversation with a specialist and not a Java specialist. Today we'll be talking about DevOps. It's a set of practices that is very important on modern projects. And today's speaker is Denis Azarov. I've worked with him for 3 years, I guess, and he's really a great DevOps engineer. So please welcome him and ask your questions in the chats. If you have any, we will try to answer all of them. Denis, passing the word to you.
Okay. Hello, everyone. Glad to see you here. Yep, as Daniela said, I'm a DevOps engineer for many years long. And today we are going here to talk a little bit about DevOps. So I'm not going to say you some, I don't know, some definition from Wikipedia because it's boring. So I create simple presentation just to follow up our process. So should I tell you regarding the agenda what we are going to talk here? Yeah, Danila provides me with the questions from the community. Yep, I divided to three groups. Sorry. The first group is very simple. Yeah, this is often asking what is the DevOps? Yeah, who is Mr. DevOps? What are they? The next group is what are they doing on projects and how to become a DevOps engineer? What should know typical DevOps engineer? So, and yep, the third topic we will not cover it a lot, but I tell you, yep, it's quite interesting. Cloud native developer, or I call it cloud developer. I believe it may be more nice. So, I believe, yep, we can start with first very simple area, just maybe to cover if somebody don't know what is the DevOps. So I try to provide a very simple, with very simple chart. Yep, what is the DevOps? Yeah, on the typical project, we have several roles. Yeah, one of the main role is developer. Yep, no objections because this is people who are writing code, who providing, who make the values, meaning that business have some demand. Yeah, and developers make this in kind of writing feature, so they make value. Yeah, but when you have a code, yeah, you need some infrastructure to deploy it to. So this is where ops operators or system administrators, you can call these people. And anyway, the sense here, yeah, that somebody should keep an eye on infrastructure. So, meaning, looking at this picture, yep, it's when we're talking about some professions, yeah, we're talking about something not changing. Yeah, if I am developer, I always only write a code, and it doesn't matter what happens with infrastructure. But it's not correct on modern projects. Yeah, in our fast changing world. Yeah, we are talking not about professions but about roles. I mean, the developer or ops, yeah, operations, it could be only role. I mean that today I could write some code, but yep, on the next week I will be responsible for infrastructure. So these two roles, developers and operators, typically it's different people, yeah. So, and they have different targets. This is very important because developers always, when they write code, write some features, services, they would like that these features and services will be delivered to a production as fast as possible. This is normal. And operations people, DevOps, even DevOps, we can say, yeah, they are responsible for another part for stability. Yep. So, and there we have a conflict. Developers versus operations. They have different goals, different targets. So, the idea behind DevOps here, yeah, to take these two cycles, yeah, and little will push and squeeze. Meaning, this meaning that we would like system administrators, operations, little bit deep in development. Yep, they, previously developers was responsible for making builds, for testing code, and so on and so forth, for making pipelines. So we and the people who invent this approach, they would like operations to be a little bit, just to be aware, yeah, about development, what are doing developers. Yep. In this way we can, provide some another goals for this both two roles, for this both two teams. It's about collaboration. It was always about collaborations. So yep, one of my favorite definition, not from Wikipedia, yeah, that developers, it's about makers of the code, and ops, operations, it's the people, yeah, who deal with this code after its birth. Yeah. So and maybe to be a little bit clear, yeah, I'm compare here approaches for developers and for DevOps. From the left side, you can see typical agile approach. Yeah, we at first in any process, for example, in development, we have some, for example, if we work on under the agile, we have some values. If somebody reads this manifesto, there are very simple values. For example, yeah, we would like to have a working code, yeah, instead of very good documentation. So it's not, it's not it's not some practice. It's just, our value. We believe, we trust in this, that if we have working code, it's better than have a very good documentation but non-working code. So the same we can do for DevOps. Yeah, there are some values that the main value here is not have good working infrastructure. Yeah, the main here is people over process over tools. It's always about collaboration between the teams. So then we go down in Agile and in DevOps. Yeah, we have some principles. For example, in DevOps, we have principle like infrastructure as a code. So it's meaning that we would like to have repeatable infrastructure, and it should be right in the code, and nothing should be changed or done with the hands. So going down, we have some methods, like in Agile, we have Scrum and Kanban. So in DevOps, yeah, we have Kanban. These methods helps us to work, just would like to say. And yeah, as for practices in Agile, we have some backlog, some continuous integration, the same for DevOps. And at the end, when we define our values, practice, principles, yeah, we can just create some tools for this. So, and we have, in effect, we have a lot of tools for DevOps, a huge number. Well, and a couple of words, maybe you ask, okay, Dennis, you tell a lot about methodologies, you tell about a lot about the projects, but what exactly they're doing? There are three big main, I believe, main areas, three primary areas what are behind DevOps on a typical project. So first, big area, infrastructure automation. It everything that you can imagine about, yeah, infrastructure and near it. CI pipelines, jobs, and a lot of things. You can write scripts to manage DNS records or something like this. So it's a big, a huge automate everything. Yeah, it's kind of slogan which are behind this. So yeah, the second big part, maybe not most preferable or liked by engineers, but it's continuous integration, continuous delivery, build, test, deploy application. Yeah, that's I believe there are a lot of engineers that they do only this part. They are calling build engineers. So, and yep, finally we have site reliability engineering, SRE is here. Yes, SRE is a subdomain of DevOps. Yeah, a lot of people can argue with it, maybe not agree with this, but it's so. DevOps mostly general, yeah, discipline, and one of the area of this, it's operate production system. In the kind of this term, you can think that DevOps are going from down. Yeah, DevOps mainly going from the code, from the development and infrastructure to the production. And if we tell about SRE, it's going from a production to down, meaning that SRE is the main target of SRE is only operating the production environment. That's all. So if something affect production, they go down to fix it, but they are not responsible for continuous delivery, for infrastructure creation and automation. So that's, I believe, all for the first part.
Okay. We don't have any questions right now, so I think we can go further.
Okay, I believe it was not so boring. Yep, guys. Another area, yeah, in our agenda, yeah, what does a typical DevOps doing on the project? So, yep, to maybe provide you with, to be aware in it, I believe I would like to, to draw something, maybe to be it more funny.
Interactive, yeah.
Yeah, so give me a second. I need to reshare my screen, I believe. Please tell me if you will see my screen.
I definitely will.
Oh no, sorry. Give me one more second.
Yeah, and while we're resharing the screen, I remind you guys that if you have any questions to DevOps, you can ask them in either of our chats. We will try to cover them all.
Wow, my browser is blocking my screen.
You can try to share your whole screen.
Okay. Now it should be visible for you guys.
Yeah, it is.
Do you see my typical user with the brick? Okay.
Yeah, it's visible.
So, guys, I would like, at first, on any project, we need to have some, I believe, some application, some idea, some solution, some solution design, architecture before everything will happen. Some people should define, just for example, we take some application, web application, for example. We take, let's draw it. We have some web application to which our users going to take some, I don't know, anything. So, and this application should have a kind, for example, of database where it store its data. It's a typical 3-tier, in my case, it's 2-tier infrastructure. So, very simple design. I should call it database. Web application, database, and user go to this web application. So let's imagine that on our project, solution architect and developers discuss, and they assume that this will work. This is very good. Then they say, okay, So we are ready to write a code for this brilliant web application, but we need something behind it. We need to store our code somewhere. We need to have some environments. We need to create this database, and this is not our business. Please provide us with infrastructure and all related stuff. So
And here DevOps comes to rescue.
yeah, here DevOps come to play in effect. So just would like to show you, which number of tasks, which number of all this stuff, typical DevOps, yep, can have. Yep. So just imagine that we are a new DevOps that came to the project and see this brilliant, very complicated architecture. So the first thing, I believe it's what they asking, where are you going to store your code? Yeah. So we can say that the first area, it's a code about code. So we can make it more wider. So, and in this day, it's mostly about Git, yes? So they said, we would like to store our code in Git. We need to create some repositories. Yeah, maybe this repositories already was done by developers, but anyway, when we create, this repositories and start coding, start make commits, then we need to start our CI, continuous integration process. Nothing complicated. We just need to define this process to configure somehow that this code should build automatically. We don't want to make it with the hands. We always would like that code automatically build it and test it in effect.
Yeah, I think we need some clarification on what is CI. It's an approach when you commit your code to some branch. It's been automatically tested and built, so you don't have to spend your time doing it, and you are sure that your code works when it is in the master branch, for example.
Yep, thank you for this clarification. So, and this always about decisions. I mean that, okay, you as a part of the team should understand what business need. And after this, it goes down. Business, okay, business need these features. We can write these features, but to write these features, we need to choose some techniques. Some Java frameworks, or in our example here, right here, we need to decide what. Sorry for this. What CI server we should use? What is the best fit for us? And we should use our previous experience to decide what is the best in our case. For example, we can use existing solution, meaning existing build server, the server where this all magic will be done. I mean, where our code will be building, testing, and in most organizations there are already have some CI servers, for example, TeamCity, Jenkins, or something like this. And you should be aware, we're talking about typical DevOps responsibility, you should be aware about the systems, and you should be able to work with all of any of this in effect. Jenkins, for example. Yes. So we put it here just to be. So after we build code and test this code, we are ready to create, in effect, that's what we call a service, or binary, or in development we call this compiled code as, and we can call it artifact. We are done. We build it, we test it, and we have something, like a package, like a binary.
Yeah, referring to our previous slide talk, it can be a Docker image, for example.
Or binary. Exactly. So this is where CI ending. Next step, it's the second part of this is sorry, it's not going to work as I expected. So I do this by my hands. Yeah, this is where continuous development starting. Yeah, with artifact
Deployment, not development.
Oh,
Or
it's
delivery.
it could be in effect discussable, but okay. Continuous delivery or continuous deployment. Okay, I got. Sorry for this. I'm just misleading. So one more thing. When we build an artifact, let's make it green because yeah, it's green. It's pass all tests. And in this case, we should decide, as Danila said, we need to decide where we going to store. Yeah, we need to store this artifact somewhere, just in case if we would like, yeah, to do something with this. So, and this could be, for example, yep, as Danila said, Docker Hub. If we have an image, it could be Docker Hub, but for other things, for other stuff, we can use, for example, a JFrog Artifactory. Yeah, or for example, we would like, sorry for this, we would like to use, for example, Amazon ECR, yeah, to store some images closer to our infrastructure. So, so this is a small chart regarding how we work with Code and what should DevOps know and what should DevOps do for the team. Okay, we have code, and as I said at the very beginning, we need to do one more thing for code. Yep, we need a platform. We need an infrastructure. We need to put this code somewhere. So this is another pillar. This is another area, domain, platform. We need to decide if we would like to have some infrastructure infrastructure as a service. I mean, in some if we need to use some cloud provider, or for example, we don't want to manage with all the servers. We don't want to spin up our own Kubernetes cluster. Maybe we just would like to, to put our images somewhere and they just running. Yep. In our case, yeah, be closer to the reality. Yeah, the cheaper is to use some, crafted infrastructure, for example, in AWS or somewhere else in DigitalOcean. So I choose AWS for our team, for our complicated infrastructure. So we have an AWS, and maybe you remember that one of the principles is to write all infrastructure with code. So, and I choose, for example, to manage with all this infrastructure via Terraform, or it could be CDK. But for example, Terraform supports CDK for AWS, but not going to go deeper. So Terraform, we have a Terraform, and now we are ready. Yeah, we see that we stop at CD because, yep, we have artifact, we have pipeline, but we have no place to deliver our code. So we need AWS.
Interrupt for a second. I think another clarification may be useful here. When you're using some cloud provider like AWS, you just rent some server in the cloud, so you don't have to replace it if it breaks down. So you rent a computer, and using Terraform, using code, you specify how many computers do you need in the cloud. So, for example, my project is very small. For me, 2 computers is enough. And Denis is working on the very huge project. For him, maybe 100 computers is not enough. And you specify it as a code, not by your hands. It's like a modern best approach.
Yep. It's depends. Sure, it's only I'm painting only one of the possible what happened on the project. I'm not going to put a bit time here. We are very close to the end. So we have yeah, we have AWS Terraform, and we create some environment. Yeah, I just would like to show you again. Yeah, for this web application, yep, we create a database, we create some networks, instances, and all other stuff, and yep, we create our development environment. So, and now we are ready to deploy our first our alpha, yeah, of web application to a development environment. So then, yeah, we need to do all other stuff. We need to make some other tests, some functional tests, and yeah, one of the things after we deploy and test our application is that we need to, to write some logs, for example, just to troubleshoot if something goes wrong. Yeah, we need some log storage. Maybe you hear about ELK or Elastic Search. Yeah, it's one of the options where you can store your logs. Yeah, maybe it's not so obvious, but another point, another big area where the DevOps should pay attention, it's only, we have not only logs, but we have a lot of metrics. Yeah, some of the metrics are generated by our application, some are generated by our infrastructure, meaning, yep, some we need to know if we have not enough compute, meaning processor time, or maybe there is a low memory or something like this. So we need to deal with metrics. Yep. We need some metrics from our application, need some information, how it's going. So, and the second point of this, that we need to define where we are going to store this metrics. For example, you can hear Prometheus. Yeah, Prometheus. We need some Prometheus to store our metrics. And another point from the metrics, that when metrics shows us that not going well, sorry, yep, we need to create some alerts, yeah, some notifications that, yep, we are in trouble. If we have metrics, yep.
For
Daniel knows.
example, your database has only 100 megabytes available, 100 megabytes of its memory, and it will crash in an hour if you don't do anything with it, and you really want alerts. On our project, we had some critical alerts, even calling people at night, some specific people, not all the developers. But yeah, alerts are very critical part of the infrastructure.
Yeah. I mean that if you have some metrics, yeah, it's definitely they should have some thresholds. Yep, it's one coming from another. So one more thing, when Prometheus by itself, it's a system where this metrics collected, it can be queried. But in effect, it's not very user friendly. If you would like to provide some nice graphs and panels with these graphs, we should use something like a Grafana. I believe most of you listen about Grafana and use it. So just to mention that it's another part of work. Yep, you need to create dashboards, you need to create some queries. It's a lot of stuff of doing. And back to alerts. Yeah, it's quite important. We cannot just now create alert like a buzz. Yeah, and that's all. Yet you need to define a process. You need to manage with these alerts. For example, you need to. Sorry, I delete this useless stuff. Yep, you need to define on-call process, meaning that somebody should be on duty and responsible for this alert, for reacting on this, to start investigation, something on this. And there are two things in other areas of DevOps work. First one is that if something go down, yeah, for example, our production is down, yep, users writing on Twitter that nothing works, and yep, we need to investigate and make, it's something like a summary. Yep, is in our world it's called it has some different names. One of them it's postmortem. Yeah, where we are investigating the reasons and what we should to do that will never happen, so that we will not go down.
Yeah, what was the root cause? Why the system went down, starting from this root cause, and how to prevent it in future. I remember writing several of
Yeah,
them.
Danila was right a ton of this. Yep.
Yeah, and
DevOps break systems, and Danila writes postmortems.
yeah, Denise mentioned reading Twitter and seeing that your system is down, but we actually once saw it on Reddit that our system was down.
Yep,
It
it
wasn't.
could be
Yeah,
faster than metrics and alerts. Yep, Twitter and Reddit. So, and one not a big area, but just would like to mention that on-call person shouldn't invent how to fix the infrastructure. We should have some instructions. Yeah, it's called
fixed
runbooks.
process. Yeah.
Yep, how to fix anything, we should have some documentation. They always work only on instructions. So this is what was grow from metrics. Yeah, it's a huge area in effect, and yeah, we have only development environment. Have a lot of the stuff. Yeah, then it grows. Then we go down by this software development, and yep, we can. Sorry, it's not so easy to to paint with a touchpad, but I try to do my best. So we have a bunch of environments, yeah, to be sure that our code has no bugs and we are good. Before we go to production, we have some other environments. One of them is a QA, yeah, quality assurance environment. Another, let's call it stage or pre-production. And we need another one, yep, which we call production. So, yep, we need to make a lot of functional tests. Yeah, testing our web application. It's yep, the area where testing, maybe manual testing goes. So we need the users, or we need some scripts which put on all buttons on our web application. Yep, and just to be sure that not product, sorry, production, that applications are ready to production.
Yeah,
So
maybe
mhm.
we need to clarify what are environments. Basically, these are the copies of your application that are available to different people. So the dev is available only for your developers and testers, and only production is available for your end users. And you don't deploy your application directly to the production because it may break down and lose you billion of dollars. You slowly deploy it from one environment to another, and yeah, usually you have starting from 3 environments, one for dev where you can break anything down and it's not a problem, something like stage where it should be much more stable, but if it breaks, yeah, again, you don't lose much money, and the production where everything is hardcore, but you may have more or less environments depending on your project.
Yep, agree. Yep, except the production. Yep, all other environments are kind of sandboxes. Yeah, a place where you can play with your code. We can test it, you can try it, and yep, then it's go to production. All this stuff. Yep, writing code, doing platform are doing to, in effect, yep, to deploy this code to a production. Yeah, to bring it to your end users. So okay, yeah. If we talking about a database, yeah, maybe some of you listen. Yeah, that we need to do a backups. Yep. So I define backup and restore domain here. Yeah, we need to do something with the database. We need backup it. So in a general, I'm not going to talk about here about this. Yeah, in general, there are much biggest area. Yep, which are calling disaster recovery. It's in a few words, it's it's a set of practice, yeah, and methods to prevent disasters. Yep, to make our application available in any conditions. We're not going to talk about it. I'm just put it here, and that's all. Recovery. So, and another big part. I'm very close to the end. Sorry. Yeah, for so long definition. Yeah, and we have another one more area. It's not so.
Could you zoom in a bit?
Sure. I'm in here.
Visible.
So, yeah, another domains, it's disaster recovery and security. Security. So it's security. I mean that invite in general. We are responsible. I mean DevOps responsible for security for infrastructure. For checking that your code are secure. So we need to implement some special methodics and run some special tools. We are not going to tell about it. I'm just put so. And one more, and last but not least, yep, we have look into this. We have code to deploy. We have infrastructure where we deploy this code, and the third part of all this is communication. It's not a technical.
But it's the most important one,
yeah. It's not. Yeah, we are not allowed in. Yep, because you can see. Yeah, all this stuff. It's not maybe not complete. Yep, all these squares are not complete list of the tasks that you are going to do as a DevOps, for example. Yeah, but yep, there are three main domains: code, platform, and communication. And this is the receipt. Yeah, receipt how to build a good solution. Yep, regarding infrastructure. And regarding the code. So DevOps should have a deal with code, with some special tools and special practices, has a deal with definitely with the platform. And yep, they should communicate between the teams to make it possible, in effect. So you can, see, it's not, a piece of cake to build a good infrastructure, to work with the code, and to build such application as we have. In this, I tried to show you what a DevOps doing and what he's dealing with on the typical project. So I believe, it's not an easy thing, to learn and overcome this, but I tried to.
Yeah, I think this diagram is not finished at all. Security includes, I don't know, 10 or 20 tools that are required, and each of these squares is one or more tools that you have to configure. So DevOps are doing a lot of job on the project. Yeah, I think we can go further. I don't see any questions asked in our chats.
That's good.
Oh, if we have a small pause here, I will make a minute of advertisement. So I just remind you that we have a free online, 100% online Java school, mjc.school. Here is our website. You can enroll there. Just go to mjc.school and study from the very basics of Java up to the cloud platforms and modern frameworks. Okay, commercial is over. I think we can continue with DevOps.
Okay. Well, I believe, the next question from your side, Daniel, was, okay, you have deal with such much activities, and definitely you need to choose between a big number of tools, and you ask me
how to select a tool for each of these squares.
Yes. So in effect, yeah. First point is your own experience. Yeah, you should work with the things that you uh, good to do. I mean that, yeah, better to use Jenkins. Maybe it's not so modern like an Argo CD or something like this, but if you're good with this, better to use this. But yeah, it depends on the project. But in the general, there are some sources what I use. The first one, we are all working in the cloud. Yeah, and there is some uh, approach. Yeah,
Foundation. Oh,
foundation. No, in general, it's different things, Daniela.
yeah, yeah.
Cloud native. Yeah, I believe you listen to these words. Cloud native. It's an approach. It's not a foundation. It's not an organization. It's just approach, which tell us that okay, we are all using clouds. We are all running containers. We would like to do this in the best manner. Yeah, and yep, it would like that this approach. Yep, help us to reach more money. Yeah, we just would like to use clouds in more effective manner. We need to optimize our application, yeah, our code to be running in clouds. So it's called calling cloud native. And yeah, here we have some foundation, yeah, yep, which are responsible for collecting best practices, which are responsible for uh, supporting the developers who are develop these tools which help us to work in clouds and in DevOps. So this is yeah, very simple graph and very simple list of tools which should be used or maybe not. Yeah, that you could, I believe, yeah, use in your projects. So it's not the end, but
Yeah,
somehow my
and
browser don't want to load all the pictures. So just a simple how to use this. In effect, it's only recommendation. Don't afraid. Yeah, Daniel. It's just cloud native foundation. Just sell. Okay, say we have some domains. Yeah, work databases, continuous integration, as we discussed. Yeah, have discussed some storage, some runtime. For example, yeah, as we have discussed that. For example, yeah, in our diagram we have here artifacts, and we would like to choose where we should store artifacts if we would like to be cloud native. Yeah, kind of. So, and yeah, we need to find here yep, storage container storage container registry domain. Yeah, how we should to use it. Yeah, we can choose it and find here some list of tools. This just meaning that Cloud Native Foundation find that these tools are very close, yeah, to this Cloud Native approach, and all of them could be useful. For example, yeah, we have here ECR and we have here JFrog. We can read about this. We can find links. Yep, we can see even market capitalization if we would like to choose in this way. Yeah, we can think, okay, we will choose the tool with the best market capitalization. Why not?
or with the biggest headcount, so the tool is supported and doesn't just die the next week after we start the
Yep.
project.
Or for example, when the last make a tweet.
I
Why not?
wouldn't really rely on this, but yeah,
Why?
okay.
Why? It's Elon Musk quite success man, so why the JFrog cannot make tweets?
Yeah, sure.
So yeah, sure. Sorry for this, guys. In effect, to be serious, yeah, you can definitely use this one not only for being DevOps, or yeah, we can use this just to observe. For example, if you use some tools on project, you can just observe what is an option, what is an alternatives. It's always useful to look around. Yeah, maybe there is a new project with which best fits to you. So it's really good thing. Another source of what we can use is yeah, it's too about uh, cloud native foundation. Yeah, but it's maybe not so. I'm not sure that they still supporting it. Yeah, but I believe it's cloud native foundation. Good, great work. Yep, and definitely you should review all the stuff, all the information, read all information on this site. But one of the initiatives is a radar. It's meaning that, yeah, we have a lot of tools, but how to understand what tools are quite new, what tools are quite mature.
Widely
And
adopted. Yeah.
yeah. And here we have some set of radars. Yep, it's not only one. There are some for security, for secret management, to store in password and all the stuff, for monitoring, observability, continuous delivery. So, and this radar helps us. It's just aside, step down. These are forming on to asking questions to such people as we are here, to our developers who are working on a project. So or are going to, but it's they are not inventing this. They are not do this from the like a marketing. They are just asking which tools you are using on your project, and we can see here, for example, Istio, maybe somebody of you here, Artifactory. It's the name of JFrog application. SonarCube, Terraform. Okay, I believe everyone here. And we can see that Terraform is highly adopted. And we have some on our radars. We have another tools on our radars. For example, it's quite old. It's 2021. Linkerd, HashiCorp Sentinel. It's about validation as a code. And I don't know, Cilium maybe here you listening. I am not, but definitely if we have something new on our radars, it deserves to review. It deserves to look at and find if we can use it, if we can learn something new here. For example, let's see on continuous delivery. We have Helm, highly adopted. Helm for deploying to Kubernetes. Maybe you don't know, but I know I work with this, and they assess Jenkins. I believe it's not not Jenkins like Jenkins, old Jenkins. I believe this is something like a Jenkins, something for Jenkins pipeline. We will not go down and find and check what does this meaning. But for Argo CD, Argo CD.
Let's not dig into the details, and probably we should speed up a
And
bit.
one more thing. I have one more link. For example, it's just an example. I'm not telling that you should watch this channel. For example, I looking at this one. I can share this link with you. It's very good guy who review some DevOps toolkits, and it's quite useful. I can see some on some videos from this channel and find really he do a really great reviews of tools. He have some charts of these tools. So this is the sources, possible sources. One more thing, sorry, I'm completely forget. And DevOps is quite mature practice, and they some big providers in world of DevOps create kind of summary, yearly summary of what happened in the world of the DevOps. So they provide so-named state of the DevOps. They provide report. It's a kind of report. They make requests. They talk with leaders in this area and ask what happened. The most famous is the one from Puppet. State of the DevOps from Puppet. It's competitor of Terraform, I believe, in some
I
years.
think State of DevOps is a much more advanced thing, so it's not for developers to read.
But it could be interesting in effect. Another one from Google. I just provide an example why it's important to review. If we put back all of the stuff inside it, we can find that in 2019, for example, the most important thing, all the people say, the most important thing to build a platform as a service, meaning that everybody make kind of customized Kubernetes, for developers to build applications inside the organization. So, but in 2020, for example, the most important things became a deployment. That's meaning that everybody managed to create clusters, and now they don't know how to deploy to it. So, and yeah, in the next year, the most important things was security. I mean, it's very useful to find, to follow trends. So they create clusters, they managed with deploy to it, and now they think how to
They
do it
leak
secure.
data. Yeah.
How to do it secure. So I mean, in that, it's a place, where you can find some, if you would like. Sure, if you like, you can find here a couple of details. So,
The last topic
sorry, for
probably
this
that we
big
have.
page.
Yeah, the last question that I had. I have heard a lot about cloud native developer. And yeah, Denis, could you please tell us who is cloud native developer and how to become one?
Okay, yes, this is another big area, and in fact, I have some relation to this topic, meaning that in our organization we are right now working on our vision, we would like to have such people, we would like to learn them, and I'm participating in this activity to creating some learning learning path, to provide people a way, how to become a cloud native developer. We call it cloud, I call it cloud developer. So what is this thing? So we tell here about DevOps, but now we tell about developer. And for developer, we can see this picture for DevOps. So in a plain words, I will show you different picture, completely different picture about a cloud developer. We still have developers and we still have operation staff roles. I mean that it's only roles. And to be effective in the clouds, to write a very, very good working application in the cloud, you need to aware about clouds. Sorry for this ugly definition, but you need to know how this works. You need to be cloud aware. You need to be Terraform aware. You need to be aware about many things that DevOps doing. And this is another approach to take these roles and little bit push. But in this and on this turn, we need to push a developers. To make them aware about a lot of stuffs. I just steal this picture from another presentation. We can see here a classic engineer who is a software engineer, another engineer is a DevOps, another is for security, and we have here solution architects. And what we would like to do, we would like software engineer to be a bit aware in these areas, to be a bit aware about solution architecture, security, DevOps thing, just to make an effective cloud application. The last part is about, very interesting thing, in fact. Even with Danila, I have argued what is the cloud native, how to do the things. And, very funny thing that when you start talking regarding your friend or your colleagues, what is the cloud native? You will talking about different things. In fact, you will say that serverless only real cloud native approach. All these containers, it's not about cloud, it's about Kubernetes. Your friends tell you different opinion, and so on and so forth. So I would like to just explain why it's important, why it's so complicated topic. There are some kind of how to say, it's named a cloud maturity. It's this means just meaning that it's so big and complicated area. For example, you can have a monolithic application that you need to lift and shift to a cloud. You cannot bring it to a pods. You cannot make a services. So it's one way to a cloud. Another way is that you just burn down anything, and start writing on a Golang or Java your new application, which in kind of microservices and something like this, but you start writing in the cloud, just a new stuff. It's another road to a cloud. So, and if this just imagine that these two developers from one project where you have monoliths and from another who have, for example, only lambdas or some functions but have no servers, Kubernetes, just go into the bar, enter in the bar and start talking about their problems. I believe that you find that they have different problems because deploying Lambda to AWS and deploying monolithic application to, for example, on-premise server requires another approach. So that people will be on another levels, of the maturity. It's just one option of maturity. This just meaning so for building we are working only with containers. For example, on the very beginning of the project we just think how to put our application in containers and that's all. And we are going to the maturity. We are learning. We are we complete these lessons. We make our homework. All these lessons learned. We create a good infrastructure, and now we're thinking how to optimize it with serverless or something like this. So this is why it's not easy, in effect, to prepare to learn a very good cloud developer, because it's not about the very, very beginning level. So in our opinion, this should be the learning path for cloud developers should be divided on a simple stages, where we, for example, on the first stage, we would like just to make some overview. What is the cloud providers? What is the containers for? What's meaning infrastructure as a code? What is CI? This is this is not, there are nothing about languages. I mean, programming languages. There are no Java, meaning on this stage, because you need to just be aware about these things to start make
understand how tools work, and even if you later have to switch to another tool, you will easily understand how it works internally, and you will spend much less time implementing it on your project.
Yeah.
Okay, and stage 2?
And stage 2, maybe it's not so beautiful for now, but stage 2 should be divided on sub-stages, like you cannot learn everything in one time. So it should be divided on some core basics, like in 12-factor application, microservices, so on and so forth. And another stages, it's for containers. For example, somebody of you would like to prepare for Kubernetes certification, like a application developer or something like this. And there are a lot of information about how containers works, how Kubernetes starts, how to make an ingress or something like this. And we should concentrate here only on containers. Another area is a serverless. For example, everybody, or maybe most of you, listen about AWS Lambdas.
I think
example.
it's a bit more, a bit too advanced, so let's probably skip it.
Okay, just skip. And two very big topics which are related to all
everyone
of
should know.
it's
Whether this
observability. It's kind of monitoring and security. So it's a very big learning path. What should developer go through to be a real mature cloud developer? But this doesn't mean that you never can reach this. Because if we're looking at stage 1, it's like unfeasible and able to do. This one, stage 1, it's a quality gate that just can show you that you able or not, if you would like to go on this area or not. This is it, in effect, regarding cloud native developer. This is it. And maybe we need to go to questions.
I have the first question. For example, I am a Java developer now, and I want to become a cloud developer, and I see these learning paths. What technology in each of these squares should I select, in your opinion? So what is the cloud provider of your choice?
Well, you can in fact, you can take any. I have no preference. For example, for cloud providers, there are three big, there are three big providers. Everybody know about AWS, Azure, and GCP, for example, and maybe some several
Any of
other.
them will suffice.
Yep.
Okay.
It's
What
just
about
a platform. About
yeah,
containers, two things.
containers?
Yeah, thank you. Two things. It's containers. It's everybody here heard, everybody listen about Docker. So you should definitely go to something like Cloud Guru, LinkedIn Learning, or something like this. Doesn't matter in effect, and learn about Docker basics. Make some.
Or watch our previous light talk.
Yes, sorry, Daniel, for this. So and make some practical. Sure, you need practice. Yep.
Yeah. Okay.
Because
Yeah, sure. With any technology, you need some practice. I just want to hear the names of the technologies that are most popular in these.
And another
rectangles.
thing that Docker just provide containers, but it's not managed containers. And typically we have a lot of services, not only one. So you need to learn about containers management. For example, Kubernetes.
The most popular nowadays, probably.
Yeah.
Okay, infrastructure as code. I think it's Terraform.
I recommend start with this. Yes, you can then use CDK, but Terraform is very easy tool, easy to start learning, and then you can decide.
Okay,
As for
continuous.
CI,
Yeah.
Sorry, continuous
Jenkins?
integration. You're right. Jenkins very good, but here, I would recommend to read a bit. I can provide another link. Regarding GitOps. Yep, it's another topic.
Yeah.
But it's a very cool thing that can help you to start working and deploying without DevOps.
Yeah, please share a link that can eliminate the DevOps on our projects. Yeah, okay. And the stage 2, I think the same technologies that we mentioned for stage 1.
That's two big areas, in effect, to discuss here. There are a lot of tools. There are a lot of need to learn. So I recommend to start with stage 1.
Yeah, I just wanted to mention that if you want to do serverless, you can start with AWS Lambdas. I think they are the easiest ones.
The idea here, sorry, I know that we have time, but we have no time more. I'm just meaning that, for serverless, you maybe not need to read more about Terraform, but definitely at start, you need to know a cloud basics. Yep. How to log into console.
We have 2 questions. I hope we can go through them briefly. Who in most cases becomes DevOps engineer, ex-sysadmins or ex-developers?
It depends. In fact, in short, it depends. I meet some developers, some Java developers, who, for example, who starts as a developer, but then understood that maybe they're not interested in writing code, and they're interested in create something feasible in like an infrastructure. So
From both sides.
Yeah. So in general, it depends on you guys. If you're interested in infrastructure, you will become an you will become a DevOps or sysadmins like me. If you would like to create a code, you will be developer. It's obviously.
And the second question, in case of migrating legacy application to cloud, what challenges have you faced so far in DevOps perspectives?
I believe that in ideal world, everybody would like to live in ideal world, have an ideal wife, kids, ideal house, ideal car. But we are living not an ideal world. So each time, when we came to any project, we need to deal with some challenges, some workarounds, and you always fighting with old code. But just think, all this old monolithic and bad code are writing right now. You are writing a code which will be old in several years, for example, and somebody need to lift and shift it. So yeah, there are a lot of challenges in effect, but it's our work, and maybe, if there are no monolithic applications, that we will not have a work. So anyway, there are a lot of challenges, and this doesn't matter. You have deal with old or fund application or with new microservices. So
Yeah, I would probably name two problems that I think would be the most difficult for me. I would name data migration. If you have a database in your data center and you have to migrate it to the cloud, it may be very difficult. And the second thing is to move the load of your users from your data center to cloud without disrupting your business. So in many cases, you cannot just stop your website for a week while you're moving. You have to do it without your users noticing it.
very good, brilliant, I believe. Yeah, it's depend. The most complicated thing, I believe. Yeah, Danila mentioned that it's about databases, and that's true. That's true because all other parts are easy to replace, but you cannot have two databases. In some cases, yes, but in effect, it is different
But
part.
you
But we
shouldn't.
have,
Yeah.
yeah. So we have for another part of this, that we have some practice, we have some approaches how to do this easier. Well, this is, I believe, that Danila and that you are learning in this community. Yeah, there are a lot of things to know. And
Yeah, and in DevOps, it's too many things to know. Okay, I don't see any more questions, so I think we'll be wrapping up. Thanks, guys, for staying with us today, a bit longer than we expected. And see you next week on the Light Talk. Thank you. Bye.